So we at Linaro Connect, and who are you?
My name is Jesse Barker, and I'm the technical lead of the graphics working group here at Linaro.
So you have a demo tomorrow?
Yeah, that's right. So tomorrow night is the big demo night for the whole of Connect, and people that have been working on things, obviously well up to Connect, as well as all this week. We're getting together to kind of showcase everything that everybody's been working on. And in our case, we've had some stuff that we knew was going to be ready in time, and it turns out we also have some things that people have just, through their diligent work, have managed to get ready at the last minute, and we didn't realize.
So graphics with ARM, does that mean all the stuff that happens with the Mali and the SGX and stuff like that?
That's right. So at the last Connect, we had one of the big things that we've been working on is the ability for different devices on the system to be able to share buffers, memory buffers directly, without having to copy across and things like that. It saves a lot of memory bandwidth, saves a lot of time. And so at the last Connect, we were showing things on the Panda board, where we showed the video driver. So we had a camera sensor capturing video and displaying it directly to the frame buffer by sharing this buffer between the frame buffer driver and the camera driver. And now what we're going to be showing tomorrow, or possibly by the time people see this, it'll be today. What you're going to see is something similar on the ST Ericsson Snowball, where the display driver, same way, is going to export a buffer to, in this case, the GPU driver. So it is actually the Mali kernel driver that will then map that buffer into user space, where an image for a texture will be rendered into it, and then that texture gets bound and textured onto an object, and then the object is displayed again through that same KMS display driver. So so you have these two subsystems sharing buffers directly through the kernel, and this is all through work that we've actually done at Linaro, and certainly there are other pieces of it that have been done elsewhere in the community. But the demo itself actually does look pretty cool. But really what it's showing is not so much the fancy graphics, but really it's how the graphics are interacting with the display.
So one of the big needs with the ARM-powered devices is to have full hardware acceleration, right? And
yes.
Is that core of what you work on?
Certainly that's involved, right? It's very, very important to us, obviously. The as capable as the ARM CPU is, part of the point of having these other devices on there, the GPU and video and codecs and things like that, is to offload some of that work from the CPU so that the power load and the workload can be shared and make more efficient use of the whole SoC. And that's really been one of the crucial themes for us, certainly both within my group, but even across Linaro, where really what we're trying to do is demonstrate some use cases that really take advantage of the entire SoC.
So it's only some use cases that do it, or is it possible to do it so it's just automatic? Anytime you would want to use it, it just uses it?
It isn't really that automatic. I mean, I think even when you look at something like RenderScript on Android, right? There's a choice that's being made for whether you're doing rendering or whether you're doing compute. But no, I think it is possible to make some of it a bit more seamless. And so that's a lot of what we've been doing. So the use case that we're building towards, and we haven't demonstrated this fully yet, but the use case that we're building towards is basically to start with something like the camera sensor pulling in and decoding an image, and then having a signal processor process that image, applying that image as a texture, rendering with that, and then displaying it through to the frame buffer. And once we get that whole pipeline enabled, I think that'll be the kind of thing that you're looking at.
Is that area of computing programming the most advanced in the whole Linaro?
I don't know that I would say that. I think that everybody, all the various domains within Linaro are doing lots of really, really clever things. The toolchain guys are doing some amazing work on GCC, and they're starting to look into ways to do something similar with LLVM. And certainly the kernel guys have done a tremendous effort. So I certainly wouldn't say that it's the most advanced programming that anybody's doing, but certainly I think it's one of the most significant pieces of work that my group's been involved in, certainly.
So when, for example, Android 4 was released, maybe the latest version of 4, they kind of switched on a whole bunch of hardware acceleration. Is that similar to all the kind of work you do?
It's very related, absolutely. So one of the things that's going on is to push to get some of these components that are now upstream in the regular kernel integrated into the Android kernel as well, and to get Android using a lot of these features that will enable them to make that more seamless for them.
And that would mean that when you run Ubuntu or any other Linux, it's just going to take advantage of that, or it's not exactly where all that code is?
Well, certainly you need support from any of the drivers for any of the devices that you want to participate in these frameworks, but certainly that's also something that we're working on. So we're working very hard to talk to the various IP vendors for the IP blocks that exist on the SoC, so that they can tie in and take full advantage, so that it does become sort of free, as you say.
So what's the next thing you're going to work on the next few weeks and months?
Next few weeks and months, I think. So my group has a bunch of things going on with respect to the buffer sharing stuff. One of the things that we're looking into now is to handle synchronization between different devices that are using these buffers to make the transitions much tighter. So right now there's potentially a bit of a gap when you hand one buffer off from one device to another, and we're looking to make that gap much smaller, so that you can reap some additional performance from the same mechanism. That's going to be big for us. On the more pure graphic side, we have a bunch of other things going on that primarily have to do with our ability to allow our landing teams to validate the work that they're doing with their hardware packs, and the developer platform guys are doing with the evaluation builds.
So how many people are you on that team working on the graphics area?
There's about 6 of us right now.
6. And you know what to do? Or is it going to be like discovery, what's it called, trying to find solutions that you don't know yet?
No. Well, part of what we've been here doing this week is to map out some of those solutions. So I think we certainly have a much clearer picture today than we did when we started here at the beginning of the week. And so I think we do have a pretty good picture of where we're trying to go. And but there are always things that will come up over time that will where we sort of have to figure some things out.